In these video recordings, we present the final version of the demonstrator developed in the SEMAFOUR project, formerly released as Project Deliverable D3.5. The outline of these video recordings is as follows. We will first give an overview of the unified self-management system as envisioned and developed in the SEMAFOUR project. Subsequently, we will demonstrate the policy-based SON management scenario, showcasing how an integrated SON management layer dynamically configures SON functions in a heterogeneous radio access network driven by selected high-level network-oriented objectives. The next three scenarios demonstrate specific multi-layer and/or multi-rat SON functions that have been developed in the SEMAFOUR project, successively addressing multi-layer LTE Wi-Fi traffic steering, the application of active antenna systems technology to do self-optimized vertical sectorization, and dynamic spectrum allocation in an integrated GSM LTE scenario. Subsequently, a demonstration is given of the developed decision support system, aiding the operator of a self-managed heterogeneous radio access network in the operational decisions regarding the expansion of its network capacity in a traffic growth scenario. The video recordings end with some concluding remarks. In a nutshell, the SEMAFOUR project has developed key elements of a self-management system for the unified operation of heterogeneous mobile communication networks. This unified self-management system can be understood as an intelligent interface between a network operator and the physical network resources, which comprises three key elements. Firstly, closest to the network operator is the integrated SON management layer. The operator is able to formulate customized high-level network-oriented objectives in terms of a weighted set of key performance indicators with associated target values as an input to this integrated SON management layer. The policy-based SON management functionality then effectively translates these objectives into a suitable and harmonized configuration of the underlying self-optimization functions. During the operation of these SON functions, the SON coordinator monitors whether conflicts arise, for instance when two SON functions try to adapt the same control parameter in opposite directions, or in the same direction but with different magnitudes. Upon the detection of such conflicts, the SON coordinator decides which requested control parameter change is granted and which one is rejected. The second component of the unified self-management system is a set of self-optimization functions. These functions are in charge of the automated tuning of the various radio network parameters, such as network selection or handover thresholds, antenna tilts, power settings, spectrum assignments, etc. These self-optimization functions can cover a single or multiple radio access technologies and have a single or multi-layer character, in the sense of targeting, for instance, macro cells only or both a macro and a small cell layer. Examples of advanced multi-layer and/or multi-rat SON functions are LTE Wi-Fi traffic steering, inter-rat dynamic spectrum allocation, and self-optimized vertical sectorization. Jointly, the integrated SON management layer and the self-optimization functions aim at a continuous optimization of the existing heterogeneous network. The third key component of the unified self-management system is a decision support system. The decision support system monitors and forecasts network load and performance. It then compares this with the operator's high-level objectives and generates timely triggers for recommended network upgrades in case of anticipated performance bottlenecks. Examples of such upgrades are the technology upgrade of one or more of the existing base stations or the placement of an additional base station of some type at a specified location within a bottleneck region. All these key elements of the envisioned unified self-management system have been developed within the SEMAFOUR project and will be demonstrated in these video recordings, including policy-based SON management, SON coordination, dimension SON functions, and the decision support system. We note, however, that in order to keep the duration of this recording within reasonable bounds, not all available demonstration scenarios will be shown, nor will the considered scenarios be shown in full detail.